metric number is 01DEP22F1011.
My name is Nurul Hazizi binti Arisman. My metric number is 10DEP22F1038.
My name is Nurul Fadlina binti Sarifuddin and my metric number is 01DEP22F1006.
Cellular network parameter is I is 2, J is 1. So first, we find calculate size of cluster and total offset. So this is how we solve the question. Okay. So the formula given is n equal I plus I multiply J plus J power of 2. So just number inside in there. So 2 power of 2 plus 2 plus multiply 1 plus 1 power of 2. So the total is 7. So size of cluster is 7. So next we solve to a total offset, where is S equal K multiply N. K is a unit for first year. So we know K is a 7 for unit first year in row, and N is a number, a size of set. So S equal 7 multiply 7. So the total is 49.
So we want to find Q. Q is frequency reuse factor Q. The formula is Q D over R. So square root 3n. We know n is 7. So square root 3 multiply 7. We got 4.583. The forward frequency reuse distance D. So we already know distance is 8 km. So same formula, we just adjust. So Q multiplied by R. So 4.583 multiplied by 8 km. Then we got 360.664 kilometer.
Okay, after we solve the question, so we got cellular network parameter. Okay. And this is a cell, and out here is cluster. So from one cluster, we jump here to got I is 2, and we jump down is another cluster. So J is 1. So we got the D. D is 39.664. So we do the same thing to another cluster. So the total cluster is 7. So the total cell is 49. So we get the 1 tier of them.
The placement of a radio base station RBS, consideration of multiply factor, including head risk with a radio frequency RF electromagnetic field. So the key factor to consider for proper distance, first, we must regulator guidelines. We know a must country to guidelines set by organization like the World Health Organization WHO and the International Commission on Non-Ionizing Radiation Protection ICNIRP. So these guidelines offer a limit on RF exposure that are considered safe. It is essential to verify compliance with a local regulation which may vary by country or region. Next, signal strength and distance attenuation. RF emission decreases rapidly with a distance from the source. Generally, the intensity of RF field drops significantly as one moves away from the base station. So the calculation of the proper distance should be based on the expected signal strength, frequency of the RF emission, and the power output of the base station.
Environmental consideration. Consideration of the geographic and environmental contents, for example, urban and rural setting, can affect the attenuation and behavior of radio wave. An urban area may have more structure that can infect or reflect signal, influencing RF rate and strength. The fourth one is health studies. Research on the health effect of RF emission has generally concluded that at level below estimated safe limit, there are no confirmed adverse health effect. However, ongoing research continue to monitor long-term explore effect, and it can be beneficial to consider study that focus on sensitive population such as child, an area that might be infected differently due to location or use patterns.
The 5 point is best practice for placement location RBS in area with low residential density can help minimize potential exposure. This would involve placing station on rooftop, commercial building or in dedicated telecommunication zones. Also, community conclusion and education can help ease public concern about health risk and precising address to safety standard and regulation. And lastly is use of modeling. Use computer modeling tools to predict RF exposure level in surrounding area based on the proposed location of the RBS. This can help identify the safety placement to ensure compliance with health guidelines.